Welcome back everyone to the Hello World Guide. This is another episode of the Doom series, and in this video we are gonna look into the drawing of sector floors and ceilings. Now in order to draw floors and ceiling, we'll need to draw the surfaces of the sectors like this. So this is the top down representation, and we'll need to draw two of these, one for the floor and one for the ceiling. However, this is going to be quite complicated because first of all, Doom does not give us any easy way to access the vertices that make up any sector. So if you have got a sector, it's not really easy to get the vertices that make it up. And even if we did have them, the GPU will need to get the data in triangles, and triangulating this will be very hard because as you can see, the sectors may contain floors and holes, and they may contain so there are some self-intersecting sectors even, and they may be concave, and that's going to be very complicated to triangulate. But the GPU will need a triangle representation like this. So this is the basic representation that we'll need to give to the GPU so that it can draw a shape like this. So how are we going to actually go about this, getting this drawing to work correctly? Now Doom provides us with subsectors, which are basically sectors that are being split up into multiple other sectors that are made up of segments, and those are convex. However, the Doom node builder does not actually store all of the sectors segments because the Doom, all the software renderer does not need to have all of the segments accessed in order to actually draw them. So it only stores the segments that lie along line depth. So this is yellow one is a line depth, and it will only store the segment that lies along this. It will not any segment that it creates that does not lie along this will not be stored, and that is a problem because we need an access to all of the segments. So we could compute everything, all of the segments from the subsectors that Doom provides us with. We could compute that easily by, well, not actually easily, but we could compute that by getting the intersection of the PSP line partition lines with this. But that would actually be very complicated as well because that would actually add an unnecessary pre-processing step to each time we need to load a level. So in order to get around that, we can use something called GL nodes. So GL nodes are similar to the nodes provided by the Doom node builder. However, they contain a bunch of extra, data for in the WOD file that make it easier to draw the sectors in an OpenGL or basically any other 3D GPU based environment. So you can see that it's giving an introduction here, and this is the official website of the the actual specifications for the GLBSP node. And this GLBSP was the original node builder that built the GL nodes. However, we are not going to use this node builder. We are going to use a more modern solution, another alternative. But this is the this website is the main specification for GL nodes, and if you go down here, you can see it tells us about what each node is supposed to contain and everything, and we'll go over this in more detail when we actually start reading those. But for now, we need to actually generate the GL node data for our WAR files. Alright, so this is the node builder that we'll use. It's called HABSB, and it's by the same guy who made the GLBSB node builder, but this is much better. And you can see that this is like the GitLab page where the source code is, and we can just compile this from source. So for doing that, you can just go ahead and you can clone it if you want to, or you can download the code as a zip or a gzip or tar file or whatever you like. And after you have downloaded it and extracted it, we can just compile it from source. So here I'm gonna move into the directory where I've extracted the AJPSP source code, and in here you can see we have got a bunch of different files here. But we are gonna just run make to actually compile the whole program. So we are gonna just run make, and you can see that it compiles each of the source code files one by one, and it should work quite well. So you can see it's compiled everything, and now we get a file called AJPSP here, which is the actual executable that we'll need to run. Now since this file we'll need to run it a bunch of places probably, so we are gonna just go ahead and copy HABSP to our binary directory. So we are gonna just go ahead and copy it there, and this way we can use it anywhere. So now let's go ahead, and I'm gonna open up my file where I've actually directory where we've got the Doom source code, and in here you can see we have got our doom1.wad file here. Where is this? Yeah, you can see this is the doom1.wad file. Now we are gonna run the actual node builder on this file. So we are gonna say ajbsp, and we are going to pass it doom1.wad. And once we run that, you can see it builds for that the nodes, and it will automatically add the GL nodes into this WOD file. And now this WOD file has been modified, and we can now read the GL nodes from this WOD file. Alright, so inside of our project file, we are going to create a new header called glmap.h, and in here we are going to define a structure for representing the GL data for our map. So this structure currently will be empty and we'll populate it as we need. So for now, we are going to open up bot.h, and in here we've got a bot read map here. We are going to also add an option for reading the GL map, and let's actually just call this map, and it's going to take a pointer to a GL map and a GL map name as well. And the GL map name is kind of different to the standard map name that we use, which is that it will have GL prefix to it. Anyways, for reading of this, I'm going to go down here, paste this, and we are going to copy the basic structure of the bot read map file here. Of course, the actual function calls are going to be different. We are going to use GL map name here, and we are going to remove all of these function calls for now. And now we are going to open a main.c, and in here you can see we are calling an engine init with the even m1 map. We are going to open up our engine.c, and in here we are going to make it read the GL map as well. So you can see that we are in our init function, we are where is it, yeah, here. So we are reading our map here. We are going to also read the GL map. So we are going to create a GL map here, and we are going to read the GL map with the what read GL map function, and we are going to change our actual error that we give to be say that it's failed to read the GL info for the map, and we are also going to actually provide it with the map name for this. So we are going to actually put the actual name of the map instead of putting even m1 here directly, and we'll need to change our map name actually a bit to actually present the GL map name. So for that we are going to allocate the amount of bytes in map name, and we're going to allocate 3 extra bytes for this. Okay, so we are gonna go ahead and set the first value of this to G and the second one to L, and similarly for basically putting GL underscore before its name, and then the third one is gonna be the null terminator. And we can use the string catenation function from the standard library to just catenate the map name on top of this, and we are gonna print the map name here to kind of figure out if we are doing that correctly, and we're gonna allocate 4 bytes to take into account the null terminator, and yeah, that should get the name correctly, and we should read the map correctly. So if everything works, we should get a correct name and we should get no errors. So if I run this, you can see it says that the map name is GLIEM1 ME1M1, and it works, which means that our data is now correct. Anyways guys, this is going to be pretty much it for this video, and I'll see you in the next one, in which we will get started to actually load the actual data that we need and start to construct our floors and ceilings from it. So that's going to be pretty awesome. Stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and bye.